Hey, welcome to Reinforcement Lens. I'm Kelvin. This channel is about one thing: making better decisions under uncertainty using measurement, feedback, and learning loops. Let me start with a situation you've actually lived. It's Monday morning. Your boss drops a task on your desk. Finish this by Friday. No perfect requirements. No perfect data. Just a messy goal, limited time, and real consequences. So you make a choice. Do you start with research or jump into execution? Do you ask questions now or risk rework later? Do you ship a rough draft early or polish quietly and hope it lands? We can map this story into reinforcement learning like this. State: it is Monday morning at work. Unclear task, limited time, real deadline. Action: it is your choices. Research versus execute. Ask now versus wait. Ship early versus polish. Reward: it is what happens after approval or rework, speed or delays. Now keep the story going. On Monday morning, you're in a state, call it S. You make a choice, call it an action, A. How you choose that action is the next part. We'll get there. Then you wait. Because in real life, rewards don't arrive instantly. By Tuesday, you get your first reward signal. Not a final verdict, just an early, noisy hint. A quick comment in a meeting. A short message: this isn't what I meant. This is a good direction. Keep going. In reinforcement learning terms, that Tuesday feedback is the reward R. For the action you took on Monday. It's imperfect, but it's enough to learn from and to decide what to do next. By Thursday, you get the second signal. Not a comment in a meeting, not a quick reaction. This one shows up in the real workflow. Maybe your draft finally unblocks the team. People stop asking the same question. Decisions get made faster. The project starts moving again. Or the opposite happens. More follow-up messages. More wait. What do you mean by this? More rework. More time lost. And here's the tricky part. This feedback is delayed. It's incomplete. Sometimes it's not even fair. Maybe the plan was fine, but the requirements changed. Maybe your work was good, but another dependency broke. Maybe your boss was in a bad mood. Still, it's feedback. It's the kind that actually shapes your next move. In reinforcement learning terms, Thursday is the state transition. Your Monday state is S combined with your action, A. Leads the system into a new state. The team is either unblocked or more confused. The Thursday outcome is a delayed reward. R, which is imperfect, noisy, but still a valid learning signal. Now here's the real question. If this exact kind of week happens again, and again, and again, can you get better in a way that's not just work harder or be smarter? Can you build a process that improves your next decision? Even when the task is unclear, even when the feedback is delayed, even when the signals are noisy and sometimes unfair? Because that's the trap in real life. You rarely get perfect information and you rarely get clean, immediate results. So the goal isn't to predict everything perfectly. The goal is to learn a policy, a repeatable way of choosing actions that works better over time. That is reinforcement learning, not a robot buzzword, not a sci-fi thing. It's a practical framework for learning from consequences under uncertainty, with delayed, noisy feedback, which is basically the definition of real life. In the last section, we only described the loop of reinforcement learning using a workweek story. Monday, you're in a situation, state Monday, you choose what to do action. Tuesday, Thursday, you get signals feedback, reward. Then, you end up in a new situation, next state. But here's the key. Feedback alone doesn't make you better. It's just events, just noise. Just a week happened. Learning begins when you do one extra thing. You turn messy weeks into a repeatable update process. So in this section, I'll show the exact learning steps so you can see how our L turns experience into a smarter next move. 1. Your life generates training data automatically. In supervised learning, you start with a clean table. Input X, the features you observe. Label Y, the outcome you want to predict. Example, past resumes gives hiring outcome. Past house features aus Preis. Reinforcement learning isn't like that. You don't get a neat X gives Y dataset. Instead, life gives you experience traces. A sequence of situations, choices, and consequences. In our story, the sequence just follows the week. Your Monday situation, your Monday choice. The feedback you get on Tuesday, the new situation by Wednesday. And the feedback you see on Thursday. That's reinforcement learning data. What you chose, what happened after, and what the world looked like next. And here's the key. You can't learn from 1 week. But after 20 similar weeks, you have patterns. After 200, you have something like a personal data set. The second thing we really care about is not one reward, because Tuesday feedback can lie. A boss might compliment a bad direction or criticize a good one, or simply be stressed. So our L doesn't optimize Tuesday mood, it optimizes long-term total outcome. That's the return. Now translate this formula. GT is the whole week outcome starting from today. Gamma is how much you care about later consequences. High gamma is long-term thinker. Low gamma is short-term thinker. In our story, Tuesday reward might be a small signal. Thursday reward might be the real payoff, that is, team unblocked, less rework, trust gained. So we want actions that lead to bigger G, which is the cumulative reward. Not just excellent Tuesday messages. Now, let's talk about the value function. Think of it as a future score predictor. It answers one simple question. If I'm in this situation right now, and I keep using my usual way of making choices, how well will this week probably turn out? So, value is not how I feel today. It's how good the story is likely to end from here. So, on Monday morning, you're asking, is unclear task plus no questions asked a high-value state or a low-value state? Does send draft early usually lead to unblocking or to rework hell? Value means, how promising is this situation, given what tends to happen next? Here's the catch. The value of a state isn't enough, because Monday morning isn't the problem. The choices inside Monday morning are the problem, so we upgrade the idea instead of asking. How good is this situation? We will ask, in this situation. If I do this specific move, how will the story likely end? We call this the action value function that is exactly the Q function in plain English, given where I am right now. If I take this action, what long-run outcome should I expect? In your story like this. Same Monday, different action, very different endings. And this is where our L becomes practical. You don't need perfect foresight. You just need to get better at estimating Q over time. Which actions tend to save you, and which ones tend to drag you into rework hell? Let's see greedy step. Do the best thing according to what you currently know once you have Q values. The simplest decision rule is, this means, pick the action that has the highest predicted long-term payoff. That's the greedy step. And now you see why reinforcement learning is so different from motivation advice. Because you're not saying, be confident. You're saying, based on the history of weeks like this, which action tends to produce the best long-run results. But wait, if you always act greedy, you never learn new options. If every Monday you always choose the same safe move, you'll never discover a better move. So, reinforcement learning adds one more human truth. Sometimes you need to try a slightly different approach to gather information.
That is exploration and exploitation. Specifically, exploitation is to use your current best-known action. Exploration is try a new action that might be better.
Here, a simple rule. 90% of the time, act greedy. 10% of the time, test a different move. That's literally how good careers are built, mostly reliable execution. Occasionally controlled experiments. Now let's see how, in Q learning, human brain updates after feedback. We would answer the core question, how does Q actually get learned? Q learning says, after you take an action and see what happens, update the value estimate. The classic update rule is this formula, don't panic. This is just a sentence. It says, old belief. New evidence, you got reward at t+1 time point, and you arrived at next state. So you adjust your belief. I translate in story terms. Given what happened, and given where I ended up, how good was that Monday choice, really? If you asked questions on Monday and by Thursday the team got unblocked, Q for that action goes up. If you stayed silent and ended up in rework chaos, Q goes down. This is learning without needing perfect prediction. It's learning by consequence. Finally, I give you a punchline. You're already doing reinforcement learning, just unconsciously. Most people do this loop emotionally. One bad week, panic, random changes. No stable learning. The reinforcement learning version is comma. Small experiments, feedback updates, slowly improving policy. So the goal isn't be right. It's not even work harder. If this gave you a new mental model, subscribe to Reinforcement Lens.